Okay, welcome to week 7, and we're looking at arrays this week. So just a quick look at our roadmap, and you'll see that we're on week 7, which is arrays. And last week we talked about more on object concepts. So we talked about overloading, polymorphism, the this operator, shadowing local variables and class variables, composition of classes, nested classes, a relationship, which is all about the composition. We also talked about blocks and scope, static, the math class, imports, and local date, and related topics. Okay, so we talked about some things again, and you'll find that quite often in these courses. So we talk about things, then we go over it again in deeper detail. Okay, in future weeks, and we go over it again a bit later, maybe. So, and in the following course, we'll go over it again. So all these topics are building on top of each other. You can't forget what you know, but we're building on top of things as we go. So we do a little bit of, for example, scope, and then we come back and talk about it again a bit more deeply. And then we come back and talk about it again a few weeks later, a bit more deeply. So all of these things are building on each other. You've got to keep them all in your mind. Okay. So being a programmer is all about having a good memory, and that comes down to practice, write lots of code, and you'll get the topics in your head and how things work in your head. Okay, so this week's all on arrays. So we'll talk about arrays this week. And here's our slides. And so we'll look at declaring an array, initializing an array, using variable subscripts with an array, declaring and using arrays of objects, and we'll search an array and use parallel arrays. And we'll pass arrays to and from methods. So we did talk about passing objects to methods in prior weeks, and we'll talk about that again this week. Okay, so declaring an array. Well, first of all, what's an array? What is an array? Okay, and an array is a named group of something, some kind of data. It could be integers, it could be strings, it could be dates, it could be employees. Okay, so just a named group of something, and you refer to the objects or the items in the array with subscripts, with numbers. Okay, so it's like a row of pigeonholes, or a grid of pigeonholes. And each pigeonhole's got its own number, and you refer to each item in the array using that number. Okay, so you use an index or a number, like you do for houses on the street. You go along to number 57, and that's house 57. Okay, and you use an index for an array to look up items in the array or get access to items in the array. And in Java, the indexes start at 0. Okay, so pigeonhole 0 is the first item in the array, pigeonhole 1 is the second item, and so on. So that's basically all an array is. It's a named group of something, and you use an index to access each element in the array, and indexes start at 0. So an array is a named list of data items, and all data items have the same type. So a group of something, a group of data of some type. You can declare an array variable the same way as declaring any simple variable, but you've got to remember some extra things, and you've got to remember, for example, square brackets. Okay, so you can insert square brackets after the type or before the type. Or after the num, after the field variable. So you can declare an array like this. Square brackets, so you can have the square brackets after the variable name, or square brackets, sorry, array. Okay. Or you can do it that way. Okay, so both of those are exactly the same, have exactly the same effect, but this is a common way you'll see it in Java. That's a Java way. You'll see it in the vast majority of code and textbooks. Okay, and okay, so we're declared an array called ints array, ins array. Righto. And that's what we've done. So if you want to run an array of doubles, put double there. If you want an array of ints, put int there. If you want an array of strings, put string there, and away you go. Okay, so that's declaring the array. That is not creating the array. We haven't created the array yet. It's just declaring an object called sales figures or ID nums, and that's the memory location where an array is going to go. Okay, we haven't actually created the array yet. And it's when you go, whatever the array name is, equals new double followed by a value, that's when you actually create the array. So you can declare an array and then create it on another line. You int 100. So we're going to store 100 integers. Okay. Or you can do it all on one line if you like. Equals new. Sorry, that should be a new. NEW. Okay. So that's declaring, creating. This is declaring the array. And so is that one. Both of those are declaring the array. And this is creating the array. Okay. So you can do it all in one statement if you like, which is a common way you'll see it as well. Okay. For what we're doing at this stage, where you know the number up front, you can declare the array and create it all in one line. You might do this way, for example, where you separate the declaring to the creation. You might do that if you don't know how many elements you need. You're going to read the elements from the file and then create the array then when you know how many elements there are, or read it from the user. How many customers do you want to store? 10. Okay, I'll create the array size 10. Okay, so that's when you might separate the two, but usually it's just all on the one line. You declare and create it all together. So the subscript is an integer contained within square brackets. So there's our square brackets for the array. So whenever you use the array, you've got to tell Java what pigeonhole you mean. So, and the array start at 0, like I said, the indexes start at 0. So the first item in the array is 0, and I might store the value 10 there. Okay, so array name followed by square bracket open, followed by an integer value, followed by close square bracket equals 10. So the first item, first element in the array has a value of 10. Okay. An array subscript or an index, that value there, if it's too big or too small, then you're not accessing part of your array, and you'll have an array out of bounds exception, and your program will crash. Okay, so if you see your array out of bounds or index out of bounds, then you've got an index that isn't correct. Okay. And so this creates storage for 100 elements. And if the indexes start at 0, then the final element in the array is, so it's 100 elements. Let's put a comment here, 100 elements, 100 integers. And indexes are 0 to, and can you guess? Okay, so indexes are 0 to 99. Okay, so the first item is at index 0. The last item is at index number 99. Okay, so ints array 0 is fine. Ints array 99 equals 456. That's okay. So you can go 0 to 99, but if you try and go at 100, that'll be an error, index out of bounds. Okay, and if you don't handle that error, if you don't have special code in your program to handle that error, your program will crash with an index out of bounds error, and Java will tell you what line number the error is. Okay. Similarly, if you try and use -1 or something like that, -1, again, that's an index out of bounds error, not allowed. Okay, so if your array size 100, you got from 0 to 99. You got 100 integers or 100 storage spaces, and their index values are 0 to 99. So keep that in mind. It's a really easy error to make. You've declared an array size 100, and you think, oh, I can use index 100 as well. You can't. You can go 0 to index -1. Okay. arrays elements numbered beginning with 0. That's just a Java standard. You can legally use any subscript from 0 to 19 when working with an array that has 20 elements. Okay, so if your array is size 20, you've got 20 inside square brackets when you create the array, then your elements are from 0 to 19. 20 storage locations from 0 to 19. Okay, so just in general terms, array of size n has n storage locations indexed from 0 to n minus 1. That's what you've got to remember. If your array size n, you've got n locations, you've got n storage locations, but they're valid, they're numbered from 0 to n minus 1. Keep that in mind. It's very easy to make mistakes, especially when you're first getting started with arrays. And to just access an individual element, you can say array name, square brackets with a number inside. That number's going to be a valid location in the array, a valid index for the array, and then give it a value. So if sale was an array of doubles, that would be okay. If sale was an array of ints, this would not be okay. Java would give us a possible loss of precision error, and our program wouldn't compile. Okay, because we'd start trying to store a double in an int, and Java doesn't like that, as you remember from earlier in the term. Okay. So each element in the array or each location in the array, you can just treat it like a normal, whatever the data type is. So if you've got an array of ints, each location in the array is an integer. If you've got an array of doubles, each location in the array is a double. If you've got an array of strings, each location in the array is a string. And if you've got an array of employees, then each location in the array is an employee. Okay, so there's our visualizing our sales figures array. I've got an array of size 20 and their locations are 0 to 19. That's the valid index locations. Okay, so 20 storage locations or 20 pigeonholes from 0 to 19 for an array of size 20. When you initialize an array, a variable with reference type such as an array holds a memory address where a value is stored. Okay, so an array is just a reference type. It's a bit like a data or a string. All the array name actually contains. So this chap here, for example, that's the memory address of where the data lives. Okay, so where the actual array lives. So it's a reference type, just like a string or a date. Okay, but an array reference type refers to an array of data, not just a single element of data or a single type of data, like a data or a string might. Okay. So array names represent memory addresses and they contain a reference to where the data lives. When you declare an array name, no computer memory is assigned. Okay, so when you declare an array, for example, here, okay, so this really doesn't, it sets up the location for one memory address, so 32 bytes, okay, 32 bits of memory, but that's not really using the memory, okay? It's when you go equals new something, that's when you actually use the memory for the array. So this is still using a little bit of memory, but not for the array. It's using the memory for the reference data, which is the ints array object. So Java's reserving memory for one reference type, which is 32 bits of data, 64 bits of data. Okay, but this is when you actually allocate memory for the array after you do the new int, new double, new string, new whatever. So no computer memory is assigned. It's not assigned for the array, but it is still assigned for the reference type. So the memory is reserved to store one memory reference when you declare an array. And when you create the array, when you say equals new, that's when the array is actually created. And 100 integer locations are opened up, or 100 doubles or 100 strings are created, and so on. The array has a special null. Okay, so if I did a system out print line here, system.out.println of that array, Java would show me that it's got the null value. Null would appear on screen. Okay. And after I create the array, then that's when this would show me a memory address, like a hexadecimal number, and that would be where the array starts. Okay. So you use a new keyword to create the array and allocate some memory for the elements in the array. So this is doing it all in one line of code. Int square brackets sum nums equals new int square brackets 10. So then we've allocated storage and an array for 10 integers, and index locations are 0 to 9. Don't forget that. 0 to n minus 1. By default in Java automatically initializes your primitive types, remember? So numbers, so int, double, and so on. They're all initialized to 0 by default when you declare an integer. So when I say int val, Java automatically initializes that to 0. And Java also takes care of this when we initialize an array. So when I declare this array here, every location in the array is initialized to 0. So in square bracket 0 is 0, in square brackets 1 is 0. Okay, so we go system.out.println, square bracket 0. It'll show me a 0 on screen, a 0. And if I go in square brackets 1, that'll be a 0. And if I go in square brackets 2, that'll be a 0. Okay, so Java automatically initializes numbers for you. And that includes arrays of numbers. So that's fantastic that you don't have to worry about initializing your arrays to zeros or whatever, if ever you create one. Okay, so here, if I system out println val, I'd see a 0 as well. Okay, so create a single integer or an array of integers. Java still takes care of the initialization of those integers for you, which is fantastic. Thank you, Java. Okay, saves you looping through setting all values to 0. Chars are automatically initialized to the null character. So when I say char c equals, or just char c like that, and I system out println to the screen, I will see the 0 character appear on the screen. Booleans automatically initialized to false. So if I've got an array of booleans, the same applies. Java initializes them all to false. And strings or arrays of dates or employees or whatever, they automatically assign the null by default. Okay, so if I declare a date or a string or an employee or an array, and I display it to the screen without initializing it, then Java will display the null memory address. So they're all initialized to null by default. So if you've got an array of employees as well, each employee in the array is null. Okay, they haven't been created yet. Okay, you can see that here, string name. And if I system out println name, we would see the word null on screen, but it's actually the null memory address. Okay, it's not the string null, it's the null memory address. And if we create an employee, don't initialize them, don't create them, we just declare them, and we display E1, we would get null as well. Okay, and same for arrays. So if we create an array but don't initialize it, we'd also see null on screen. Okay, so it's only when you go equals new employee, equals new square brackets, equals int, new int square brackets 10 or something, that's when the memory is allocated for the array or the object. Okay, so keep that in mind. If you know the values you want to put into the array, you can hard code them. Okay, so these are called hard coded arrays. In other words, you type in the values by hand at compile time or before compile time, and then you compile your code and run it, and your array doesn't change. Okay, so you can declare an array of ints, in square brackets 10 multipliers equals 10, 20, 30, 40, 50, 60, and so on. Okay, so you're providing the values with inside curly brackets. Make sure they're curly brackets, opening curly, close curly. Make sure you put square brackets there without any numbers in it. You don't want to put 5 or 10 or anything here. You want to let Java allocate the array size. There's no new operator. There's no square brackets over this side of the equal sign. Okay, so an array of ints, vals, or maximums, or whatever you're creating equals open curlies 100, 200, 300. Okay, so curly brackets, that automatically allocates an array of size 3. There's 3 elements. And the first element, 100, is at index location 0. The 200 is at index location 1. And the 300 is at index location 2. So the first element, the second element, the third element. Index locations are 0, 1, and 2. Okay, so the array is size 3, and it's got 3 storage locations, numbered 0, 1, and 2. You can do the same for strings. Open curlies, and then we're creating strings. So Mike, Frankie, Bella, and so on. Okay, so we're creating an array of strings. Again, it's 3 strings. And Mike is at location 0. Frankie is at location 1. And Bella is at location 2. Three indexes 0 to 2. I might even list them out for you to make it a little bit more. 1 and 2. Okay, and this is an array of size 3, and indexes are 0, 1, and 2. Okay, so if we go system.out.print screen, names, square brackets 1, what would I see on screen? What would I see? I would see that the string in the names array at index location 1, which is the second location in the array. So I would see Frankie on the screen. Okay, don't fall into the trap of thinking this is 1. That's index location 0. That is location 1. Okay, you've got to be very careful when you think about arrays. They start at 0. You've got to get that into your head really quick. Okay. So when you do this, called a non-default array or a hard-coded array, non-default array, I guess you can call it that. I like calling them hard-coded arrays. And that's when you provide a list of values. They're always separated by commas. Okay, they're always contained inside curly brackets. And don't forget your semicolon at the end. Okay, and you don't use a new operator. You don't use a data type. You don't say equals new int or new whatever. And you don't give a size. You let Java work out the size of the array based on the items you provide. So just provide values separated by commas, and Java work out the size of the array for you and set everything up for you properly. Okay, so this is populating the array with hard-coded values, but we can also just declare an array or create an array and provide the values as well. Okay, so you can populate array this way when you know what the values are. You populate it with ints or strings or whatever you like. Okay. Or if you don't know what the values are and you're getting them from the keyboard or from whatever, from the user, you might have a scanner object, input array, square bracket 0 equals keyboard or whatever our scanner object is, dot next int. And we might get the second element from the user. Okay. And then the third element, and so on. In fact, we wouldn't write code like this, of course, now that we've done loops. We would use a loop. So for int k is equal to 0, k is less than, okay, 100, k plus plus. Let's display all values in the array. So system.out.println, and it's our array. We'll assume it's int array we're talking about. Square brackets k. Okay, so here we're using, instead of putting the value 0, 1, or 2 in there, we're putting the value of k, whatever the value of k currently is. So it starts at 0, So we're going to see the value at location 0, and then we'll see the value at location 1, and value at location 2, and value at location 3, and so on. And we'll keep going while k is less than 100. Okay, so we'll see the values for locations 0 to 99. Okay, so we're keeping, by making this a less than sign, we're keeping array k less than our maximum index value, which is 99. Okay, so 0 to 100 is our index, 100 is our number of elements, and valid index locations are 0 to 99. Now, this is what I've done here is bad practice, because I've got the value 100 there, and I've got the value 100 there. Okay, so don't go doing that sort of thing. That's bad code. Okay, because if I change the array size here, I've also got to remember to go through and change all the 100s to whatever throughout the program. Okay, and make sure I'm changing the right ones. Okay, because there could be hundreds around for other things. So you don't want to do a global search and replace. Okay, so a much better way to do it, you could do this. This is much better. You can use the array to give you the length of the array, and it's dot length. So this is a property, not a method. So there's no round brackets there. When we talked about the length of a string, system.out.println, we use name.length. That would tell us 4 characters. Okay, because this is a method for the string class. So we're getting the length of a string name. So you've got to have round brackets there. But for arrays, the length is a property of the array. It's not a method. You don't go length round brackets. That would give you an error. Okay, just length. Okay, so by using the length of the array, you don't have hard-coded, the value 100 hard-coded throughout your program. You can just use it whenever you like. Okay, so length. Code. So bad code and good code. Okay. So array name dot length will give you the number of elements in the array. And you can go from 0 to that value -1, or loop from 0 to while you're still less than that value to get to all the index locations in the array. Okay. And like we're doing here with our next int, if we were getting 100 integers from the user, we could get that in a loop instead of doing this sort of stuff. We wouldn't want to do that 100 times. So we could do it in a loop. So we do it up here before you display the array. And we go int array square brackets k equals kb.nextInt. Okay, so get the next integer from the user. And you probably want to prompt the user as well to let them know what's going on. So system.out.println, enter integer. So that would tell them to enter an integer, but it wouldn't tell them where they're up to or how far they've got to go. So you probably want to display a bit more information than that. So enter integer plus k. Okay, so then they say enter integer 0, enter integer 1, enter integer 2, and so on. Again, they wouldn't know how far they've got to go, and they're also starting at 0, which might confuse some users. Is the location 0 thrown away? What happens with location 0? So might as well start at 1. So the way to do that is to go k plus 1 and put it in round brackets. So Java means you're doing this calculation and then concatenating it onto the string. So then the user would see enter integer 1 for the first integer, integer 2 for the second integer, and so on. But we're still putting it at the correct index location, 0 to 99. Okay, so dealing with arrays and loops. That's the beauty of using arrays. If we didn't have arrays and we had to get 100 integers from the user, we would probably have to write code like this, where it was integer 1, integer 2, integer 3, up to 100, which would be a nightmare. Imagine if we had to get 1,000 integers. Okay, but we can do the same sort of thing with a loop with just a few lines of code. And displaying the values again, if we didn't have integers, if we didn't have arrays, we'd have to write system out print line integer 1, integer 2, integer 3, 100 times or whatever. But now we know about loops and arrays. We can do it all with a loop. Much easier, much shorter code. Okay, so that's the power of arrays. You can store a whole group of items and reference it using one name, for example, inst array, followed by square brackets, followed by an index. Okay, so it's really makes it easy to compact your code when you need to store a lot of something, a lot of employees, a lot of names, a lot of temperatures, a lot of days in a month, whatever you need to store. Arrays make it easy when you get a lot of objects or a lot of items. Okay, so a scalar is just a primitive value, an int, for example, is a scalar. And the power of arrays is that you can use subscripts that are variables rather than constant subscripts. So that's what we just looked at here. And here's an example using a loop, sub equals 0, subs less than 5. And here we're adding 3 onto each element of the array. So if the scores array originally had a value of 1 at each location, this would add 3 onto that location. So there'd be 4 at each location in the array. Okay, so here we're using sub as our loop variable and as our array index. We're starting at 0 and looping while sub is less than 5. And updating the value at a location in the array, we're adding a 3 onto it. Okay, so when we said total equals total plus 3, and we looked at the shorthand, total plus equals 3. That's all it's doing here. So those two lines of code are the same. That's all it's doing here. It's just a shorthand for scores array sub equals scores array sub plus 3. Okay, when an application contains an array, you use every element of the array in some task, and you can perform loops. You can use every element if you want, or you can use just the elements you need. So if you declare an array of size 100, you don't have to use all 100 elements. You could just use the first 10 for one run of the program, and then you could use maybe all 100 next time, and then maybe just a 50 the time after that. So you can allocate an array of size whatever, and just use part of it if you want to. And you can perform loops that variable the loop control variable starting at 0 usually. So 0 is the first item, usually start at the first item, and end at 1 less than the size of the array. So if it's size n, like I said up here, that's the golden rule. When you've got an array of size n, then you've got n storage locations, and the indexes are from 0 to n minus 1. Don't forget that. That is really the golden rule. It's also a good idea to declare a constant. So we looked at using the array length here to get the size of the array, and that was good code. That's fine. But it's also probably better code to make it so that you use a constant. So let's redo this code here, and we'll use a constant. So final int max size equals 100. Max size to set up the array. I won't worry about that comment now. Okay, so we're using a constant, okay, to create the array and declare it, and then we can use our constant here. So down in your code now, you can still do that. That's still good code. We're using the array length. That's fine. Or if you want to, it's still good code to use the constant. So either of those are fine. You can still use the array length, or else you can use the constant that we declared. And both of those are equally good. I wouldn't say one's better than the other. Okay, but this is still perfectly safe, and this is still perfectly safe as long as that constant is the one that's used to initialize your array, create your array. That's safe. If it was some other constant, if it was max temp, which could have any old value, then you'd be in real danger. But whatever the one's used to initialize and create your array, that's perfectly fine. Both of those codes here, this one and this one, are both equally safe, equally good. Okay, but that code, like I said up here, where you're using the value 100 throughout your program, that's bad, bad, bad. Do not do that. Because if the size of the array changes, and we change that, we've got to go through all our program and change all the 100s in the right places to whatever the new size is. Bad, bad, bad code. So field is an instance variable in a class and automatically assigned a value for every array created. So the length field, or the length property, okay, so that's what we're talking about here. The length field can help you work out the size of the array as well. So scores array.length gives you the size of the array, the number of storage locations, the number of elements you can have. So as long as you loop through from that 0 to whatever the index is less than the length, then you're fine. Make sure it's not less than or equal to, because then you'll exceed your array size. Okay, make sure it's less than. Make sure that's a less than, not a less than or equal to. That'd be an error. Okay, because you're going to blow your array size. You'll have an array size exceeded. Okay, so make sure it's less than there and less than there. But both of those are equally good. So, if you use less than or equal to there, or if you use less than or equal to. Instead of, okay, so just be very careful of that. It's very easy to do as well. But Java will tell you pretty quick. It'll give you a compilation error. It'll give you a runtime error. Your program will crash, and it'll say index out of bounds. Okay, so then you know you've got one of these issues going on. Okay, so be very careful of that. Be very careful of that situation. Make sure you're using less than the length or less than the max size. Okay, just like this code up here. Those two bits of code here are perfect. Just use those. So the length is a property of the object. It's not a method, so you don't go length round brackets to get the size of an array. It's just dot length. It's a property of all arrays in Java. And you cannot be used as an array or an array method, so you can't put round brackets there. Once you've got an array, you can use an enhanced for loop. Or there might also be compact for loops as well. I generally call them compact for loops, enhanced for loops. Okay, so to loop through all items in our array, we could do either of those. Okay, or we could do a shorter version for value in our array system.out.println val. Okay. So this will display all values to the screen. This displays all values to the screen, and this displays all values to the screen. So how much shorter is that code, eh? So you can use a compact or an enhanced for loop with your arrays. Okay. If this is an array of strings, let's go back up and get our names up here. So I'll just show you how you can do it for. Oh, sorry. So you got to have int val. Okay. So you got to tell Java what type it is in the array. So for every integer in the array, we're going to display the value to the screen, or get user input, or calculate the total, or do something with it in a loop. Okay. Let's do the same with names. Okay. So we do the same sort of thing. We could display them all to the screen using the names array. We could use the names length. Okay. So that's displaying all the names to the screen using a standard for loop. Or we could use a compact or an enhanced for loop. So for each string called str in our array of names, system.out.println str. So you can see it's a lot less code. I could put our curly brackets in again if I want. You can see, so this is for each string in our array names, and we start at location 0, and Java automatically loops through all strings in the array with this loop, and we can display them to the screen. We can work out the length, we can work out the average length, we can total up the number of characters, we can do whatever we like. Here I'm just displaying them to the screen. Okay. I generally put my curly brackets on, even if it's one line of code. 1 often becomes 2, and anyway. Okay, so the enhanced for loop or the compact for loop, very powerful. So why would you use this one over this one? Okay, well, if you need to get access to the value of k, for example, if you needed to say name plus k plus 1, so name, start with name 1 onto the screen. So this one here tells you that you're outputting name 1, name 2, name 3. If you want to have a counter here, well, you haven't got the counter anymore. So if you want to have the counter as well, so you can display what name it is onto the screen, then you would have to introduce a counter. For example, int count is equal to 0, and then add 1 to it here, count plus plus, and then include it in your output here, name. Okay, so it gets a little bit awkward. If you're having to do this sort of stuff, where you're declaring an extra variable and adding 1 onto it, you might as well just use an old for loop. Okay, you might as well just go back and use an old counter controlled for loop. Okay, so all this extra stuff you got to do. This is now actually 1, 2, 3, 4 lines of code, whereas this always just 2 lines of code, really. Okay, ignoring the curly brackets. So I'll just put this code back how it was. And I'll put the new version in down here. So if you need to. If you need to access the element number or the element location in the array or the index or whatever you want to call it, then you've got to introduce an extra counter and add 1 to it. Messy. This is much cleaner when you have to do that sort of thing. Okay, so here we've got some code, and we're going to use part of an array. Okay, so we're an array size 10, and we've got the scores. So the score is 0, the count's 0, the total 0. So initializing all the things we're going to keep track of. When the user wants to quit, they enter a value of 999. Max is 10. Okay, now I would like to see that constant move up here and use max used here instead of having 10 repeated in 2 places. So this is not good code. I would like to see max used for the declaration of the array here. So move that up above the array and use max here as well. But anyway, look over that. So enter a quiz score, get the next bit of input from the user and add it and store it in score. And while score is not equal to quit, in other words, while the user hasn't entered 999, store the score at that location in the array. So it's location 0. Add that score under the total. Total plus equals scores count. And add 1 on the count. And if count is equal to max, so we've reached the maximum we can store in the array, then we'll set score equal to quit. So that quits our loop. Otherwise, ask the user to enter another score. Okay, so this is just to keep looping until the user enters 999, or until we hit the array size, which is elements 10, until we exceed the array size, which is 10 elements, 10 integers. Okay, so this not a bad little loop. We could actually do it a bit better, and that might be something you could try for homework. Is that you can save duplicating this here and down here again. Okay, and we looked at strategies for doing that back in week 4 and week 5. So, and then down here, the following scores are entered. For x equals 0, x is less than count. So count keeps track of the number of scores that are entered. Okay, so we might have an array of size 10, but the user might have only entered 1 score or 5 scores or no scores. Okay, so we're going to loop through and display as many scores as the user has entered and display that score to the screen. And if count is equal to 0, or if count is not equal to 0, we could calculate the average. The average is total times 1.0 divided by count. So we're multiplying by 1.0 to get an accurate average. So if it's 3.56, we see 3.56. It doesn't get truncated to 0. And otherwise, we can say no scores were entered. Okay. So we might have an array size 10 or 100 or whatever, and we might only use part of the array. Okay. Might not even enter anything. We might just enter 999 to quit here. This loop never enters, and we're not going to display anything there because count 0, and we'd see no scores rendered on the screen. Okay. So have a play with that. I recommend you change that example to use the methods we talked about back in week 4, week 5, where we avoided having this repetition here and here. Okay, so just changing your code slightly, you can avoid that repetition. If you want to create an array of employees, okay, so arrays of objects. Okay, we've seen that really already with names. Names is an array of objects, an array of string objects. Okay, but now let's create objects of our own classes. Okay, so employee, square brackets, emps equals new employee. Okay, and we could store 100 here, and that would give us an array size 100. Or even better would be to use our maximum that we just talked about up here. Let's go use that. Okay, so max size. Okay, so that's a much better way to do it. So that's given us storage for 100 employees. And just going back to what I talked about earlier, if I go system.out.println and I display employee square bracket 0, what would I see on screen? Let's go back before you answer that. Think about this. Okay, what would I see on screen for this code here? And the answer is I'd see the null memory address, wouldn't I? So I'd probably see employee followed by ampersand followed by null. Okay, or else I just see null memory address. Okay. Okay, so if I display the value at location 0, I've created the array of employees, but I haven't actually created the employees yet. Okay, so this would show me null as well, or else employee ampersand null. Okay. We just say null. Okay, so what you need to do for each employee in the array is you need to create them. For example, emps square bracket 0 equals new employee square brackets, new employee. And then up here, when we created an employee, I said E1 equals new employee through their name. Remember, we've done this in prior weeks, and there's employee ID and so on. Okay, so that's how you create an employee. And so do the same thing down here. So each item in the array, or each location in the array is an employee. So you say that location equals new employee. Emps1 equals new employee, Frankie. And so on. Okay, so this creates your array of employees, but it doesn't create the employees. Each location in the array is initialized to null. Okay, so you've got to then create the employees. And here I'm doing it hard-coded data, but I could also be getting input from the user and going kb.nextLine and kb.nextInt to get the next string and integer from the user. Okay, and kb next line and kb next. So I could be doing that in a loop. And here I'm just using hard-coded data. Okay, so if I had the prompt set to get the data from the user, I could say, and it was the scanner object KB, I could say next line there and kb.nextInt. I could create the employee that way. Okay. And the same applies down here. Okay. And if you're asking the user to enter 100 employees, you could do that in a loop. Let's do that in a loop. So max size And we could say enter employee K+1. Okay, so we're going to show them for 0, we're going to say enter employee 1, enter employee 2, and so on. So we start at 1 with K+1 inside brackets there. And then we want to get that employee from the user. So it's the same sort of code, but we put K there. Okay, so employee K equals new employee. Get the next line of input from the user and get the next integer input from the user. If you don't get the next line, you could just get the next word or whatever. Sorry, that should be lowercase next. Lowercase next. Lowercase next. Okay, well spotted. Okay, so that gets you the next bit of data in for that employee. So we're getting all the users from the keyboard here now. If we've got an array size 100, the user's got to enter 100 employees. If we've got an array size 5, the user's got to enter 5 employees. So you could do this trick here we talked about earlier to allow the user to enter just 2 employees. They could enter 999 for the employee ID when they want to quit or something, or enter a blank name or whatever you want to choose to quit. So you could control it that way as well, and make sure we're not going beyond the maximum size of the array, and keep prompting them while they want to enter more data. Okay, so you could change your sleep here. Instead of forcing them to enter all 100, they could enter 5 or whatever they wanted to enter by just adopting this strategy. Okay, so have a go at that too. That's some good homework for you. Do. Slide 14, to enable user to enter just 5 or 10 or whatever employees. Okay, so that's something for you to do, students to do. And also, like I said earlier, adopt the strategy on slide 14 to reduce, to eliminate code. Also, remember we talked about the max. Move max to top. And use this to declare the array. Okay, so 3 things you can do there for some extra practice on top of the cheat questions and textbook questions and whatever. That's week 4 or 5, we did that sort of thing. Let's see, week 4 or 5. Okay, so it's all good practice for you. And of course, once you've got all the employees set up, then you can call whatever methods are available for an employee. Okay, so to display this employee here, system.out.print screen, I might have called I might have called methods, sorry, e1.getName, e1.getName, e1. Okay, so if the employee class had methods like getName and getID or whatever, then I could call those and get the details for employee 1 and whatever other employees I had. Okay, and the same thing down here. So let's loop through all employees, display them all to the screen. And we'll display the employee number as well, which is our counter, employee count plus, and we'll get that code there, put it up here, but it won't be E1, it'll be EMPS-K, EMPS-K, EMPS-K. Okay, so we'll see employee 1 is Mike 123. We probably want to close the round brackets again after that inside quotes. The opening round brackets there, close round brackets. So with the employee ID after the name inside round brackets, if you want to display it that way. Okay, so that'll display all employees. If you'd used this strategy here to allow the user to get out early, then we could just loop through while caseless and count whatever your counter is for counting the number of employees the users entered so far. So at the end of 5, you can just display 5. If they enter 100, you can display 100. Okay. You can also use your you can also use your compact for loop or your for each for loop. Okay, so let's do that. Again, once you do that, you can't get access to the account, to the counter. So I have to change our code a little bit. So let's do that. For each employee called E in the emps array, let's do a system.out.println. So our employee is now E. Every time through the loop, our employee is E. So we can just grab this code here, change that to E. E dot and E dot. Okay, so whatever this chap here is called, that's what we're using to get access to that location in the array. So E dot get ID, E dot get name. That will get the employee name and ID at that location in the array. And we're looping through all items in the array. For each employee E in the emps array, we're going to call the get name method and the get ID method and display the results to the screen with a bit of string data around it, brackets and stuff. Okay. So that's using the compact for loop. The traditional counter control for loop and the new compact for loop that we just seen, the for each loop. Okay. Here we're calling for each worker in our emp array, we're going worker.getEmployee num, and then adding on the salary as part of the string worker.getSalary. So it's for each worker in the employee array. So work is what you use down here inside the loop. Like we created an array of names and things earlier, and integers, you can create an array of strings. Here's another array of strings we've hard-coded as well, just like we did with names earlier. String department names equals accounting, human resources, sales, and so on, whatever you want to place there. Okay, so remember the rules. You put square brackets there. You don't say equals new. You make sure you've got to use curly brackets, no square brackets on this side of the equals sign, no sizes inside square brackets. Let Java do all that for you. So Java will look at your data and say, okay, there's 3 strings there. I need an array of size 3. Okay. And then you can use the length property. Int a equals 0, a is less than dep names dot length. System out print line dep name square brackets a. Okay, so slide 17. We could also use a compact version of the for loop. I'll just move this over a little bit, just so you can see both. Okay, so let's do this same thing, but we'll do it without having a, and we'll do it using a compact version of the for loop. Okay, so for something in something system.out.println followed by something. Okay, so you got to fill in the blanks. Okay. So the first thing you got to think about is what type of data are you dealing with? What type of data is in the array? And it is a string array. Okay, so string. And what's our array name? And it's called department names. Okay. So for each string, something inside the department names array, we want to print it out to the screen. Okay. What do you want to call your string? Well, we just call it S or str. What do you want to call it? It's only a temporary name for use inside the loop. And for each S, then we can print out each str. So for each string inside the department names loops, we're going to call it str inside the loop. I'm going to loop through and display that many strings. Okay, so the old traditional counter control loop or the new for each loop. Use whichever one you like. And unless you need to get access to the counter, you could shorten your code a little bit and use the for each loop if you wanted to. Okay, you can determine whether a variable holds one or many variables. One or many values. You can use a series of if statements and you compare the variable to a series of valid values. Okay. Okay. So if you just want to see if it contains one valid value, it's just a simple if statement. If you want to see if it contains one of a range of valid values, you could use a range of if statements: if, else, if, else, if, else, if, or you could use a loop to compare the values to known good values or values you want to recognize as good or significant in some way. Okay, so get the item ordered from the user or from a file or somewhere, and if item order is equal to valid values X, then we could say valid item is true. So this could be a product number or something like that. Okay, so if we've got products 101 and 102 and 103 and 110, if they were valid values that we stored in the valid values array, and we're asking users to enter an item ordered, we could check if they've got values, if they entered one of those values. Okay, if it's in the valid values array, set valid item to true. Okay, so this is looping through an array to see if something is inside the array, and if it is, we're setting valid item to true. Let's look at the complete code there, or more complete. So let's have valid values. So int square brackets valid values equals. Let's just pretend they're 101, 102, 103, and 110. Don't forget your semicolons, and we'll say Boolean valid item false. So we're assuming it's false. Try and prove otherwise. And we'll int item ordered. I think that's what they called it there. Item ordered. Yep, item ordered is equal to kb.next int. So we're getting the next item from the user. KB is our scanner object. We've got a prompt going on now. I'll let you fill in the blanks, and then we've got our loop. Zero. K is less than valid values dot length. It's a property, don't forget, not a method. So it's just length without round brackets. K plus plus. If item ordered is equal to 1 in the array, valid values square brackets K, then we could say valid item is true. And down here we could take action. If valid item is not equal to true, we could display. Okay, so that's sort of a snippet of our code. How we're fitting that in. So we've got a list of valid values from somewhere. Here it's just hard coded, but it could come in from file or database or somewhere. And here we're getting the input from the user, from the keyboard, which is our scanner object. So scanner. And we're looping through all items in our array. And if we find one that matches, so if they enter value 102 here, if the user enters 102, we check it to 101, no, 102, we found a match, so we set valid item to true. Then after the loop, we can do whatever checking we want. If valid item's true, we can do other processing. If valid item's not equal to true, we could do other processing and so on. Display error messages, display success messages. Get the next bit of input from the user. You might get the ordered the item number, then you might get the item quantity that I want to order. So get the item number first, make sure that's valid, and then get the item price or item the number they want to order, and so on. So righto. So, and of course this could all be in a loop where we're asking the user over and over again to enter something that's valid. Okay, so just like we've done in our prior weeks, we've looked at that strategy. And in the assignment, you did it as well. Okay, so that's a more complete bit of code there. Is there any way we could improve this loop? Imagine we had thousands of items here, not just 4, but thousands. Is there any way we could improve that loop? Okay. So what if we look searching for item 102, and it's the second item in the array, but we've got an array of size thousands or millions even. Could be an array of size millions. How can we improve that loop? How can we bail out early when we find a match? How can we exit the loop early? Okay. So put curly brackets here. And we could say K is equal to something that exceeds we want to make it say K no longer loops, our variable K no longer loops next time through the loop. So we can set it equal to valid values.length. Okay, so we found a match. We don't want to keep searching, so we'll set K equal to valid values.length. So if we find the item after 2 passes through the loop, we're not going to do the other 10,000 passes or whatever it is. We're going to exit early. Okay. Now, if ever you write this sort of code, it's very important. Put an exit loop comment after it, just to make it really clear that's what you're doing. Okay. So we're setting K equal to the maximum, the array size. So this condition here will be violated next time we're going through the loop. So our loop will exit and we'll come down here. Okay, so it means we're exiting out of the loop early. As soon as we find a match, we're out of there. Okay, we're not going to keep looping through all 10,000 items trying to find if there's any more matches, because we found a match. Okay. Now, if we were doing code where we wanted to find all matches, not just the first one, we would not want to do that. Okay, you'd want to loop through all items in the array. But here, we just want to find if the product code's valid. So as soon as we find a match, we want to get out of there. So we're out. Okay, parallel arrays. Parallel arrays. Parallel. Parallel. And so let's say you've got an array product codes. And you've got product code 101, 102, 103, 110, and the product is keyboard. Product code is a mouse. This product here is a 16 gigabyte memory upgrade. Product 110 is a 32 gigabyte memory. Okay, and so on. Let's just say, I'm just making up products here. So in your system, in your shop, product code 101 is a keyboard, a USB keyboard, or some sort of keyboard. You've only got one. If you've got many, you might have 102, 102, 103. They're all different types of keyboards. Here in my shop, I've only got one keyboard, one mouse. They got the mouse. 103 is a 16 gig memory wafer, and 110 is a 32 gig, and so on. I could have many other products as well. So let's store this data. We could have int square brackets product codes equals curly brackets, close curly brackets, 101, 102, 103, 110, and we can have products. So there's strings, square brackets, product names equals open curlies, close curlies, semicolon. Not a bad idea if you do that to get in the habit of that straight away. And it's just these products here. So I'm going to put each one inside closing brackets, a comma between them, open closing, open quotes, close quotes, comma between them, open quotes, close quotes, comma between them, open quotes. Okay, and not a bad thing to do if you do this sort of thing is to line everything up so it's nice and neat. So it's really easy to tell what belongs where. Okay, so now if I'm using product code 2, okay, so if I found a match on product code 2, then what's the product name the user's entered? Okay, and of course it's 0, 1, 2. Don't forget your array start at 0. And it's not a bad thing to do, especially when you're getting started with arrays. Put the index numbers here at the top: 0, 1, 2, 3. Okay. If you're doing an exam question or a tutorial question that's asking you about arrays, Put the index numbers in there. You write them in yourself. Okay. If you're doing it on paper, write on paper, right above the arrays, and make sure you start at 0. Okay. That just eliminates one more way you can make a mistake. So product code square brackets 2 is 103. That's the product code. And if we look up the product name for that product, it would be 16 gig of memory. Okay, so that's all a parallel arrays is. You've got multiple arrays, all containing related data. And the data must be kept in order. Okay, so if you do a sort on this array and you sort it alphabetically, you've got to make sure you sort this array up. And if you move this item to the start, you've got to make sure you move the 103 to the start as well in that array. You've got to make sure you keep everything in line. If you rearrange the order of this array, you've got to do the exact same operations on this array. Okay, and then you might have prices as well. Double product prices equals, and we're going to open curly brackets, close curly brackets, put a semicolon on, make sure you get in that habit. Okay, and the price for the keyboard's $19.99. The price of our mouse is $14.99. The price of our 16 gig memory upgrades, $22.50. And the price of our 32 gig memory upgrades, $31.45. Okay, so keep everything in line. So if we did a sort by product name here, and we rearrange data, you've got to rearrange this data here exactly the same way, and you've got to rearrange this array here, this data here exactly the same way. So if you move this item here to the first element in the array, you've got to move the price to the first element, and you've got to move the product code to the first element as well. So any changes you make, you've got to keep everything in line. And so that's a very So if you sort one array, the other arrays must have the same move operations or copy operations performed on them. When you move data around from one location to another, when you swap, same swap operations performed. So when you swap those two elements, you've got to do the same in all the other arrays as well. Okay, otherwise things are out of step. Suddenly you've got a 32 gigabyte memory module costing $14.99 or something like that, and it could be a disaster. You could be out of business real quick. Okay, so parallel arrays. And then the product prices for location 2 would be $22.50. Okay, so all the elements at location 2 of the arrays is all related to the one product. At location 3, it's all for the one product. The product code for that product, the description, and the price. Okay, and so on. You could extend it further. You could have int stock quantity. You know the number of items in stock for each item. So for keyboards are quite popular. We've got 5 of those in stock. Mouses, they're pretty popular as well, but we've only got 4 of those in stock. 16 gig memory modules, nobody's buying these days. We've got 1 in stock and we're going to do a sale on it soon. And 32 gigs, that's more popular, and we've got 3 of those in stock. Okay. So each time somebody orders one of these, if you had a little order system set up, you could take one off. And if the number of that item in stock is 0, don't let someone order it. Okay, so again, you're checking up here. You could check if the item's valid, and then you could check the number in stock for that product as well, and see if it's greater than 0, then you can allow the user to order it, and so on. Or check how many. If they want to order 5 and there's only 1 in stock, you could say there's only 1 in stock. Do you want to order just for 1? Okay, so you can see that sort of thing. Okay, so just by having a few arrays like this, 3 or 4 arrays, you can set up your own little stock control system. Okay. So parallel arrays. Okay, so up here we used a for loop while searching. You could also use a while loop. Let's just do that with a while loop. A while valid item is false, and you could set int k is equal to 0. Okay, and then index. I'll call it index. Index. Okay, so here we're doing a while loop to do the same sort of searching. Okay, so because index is declared outside of the loop, it's still got scope here. Okay, so we can use index to look up whether a product's in stock or what its name is or whatever we want to do in other arrays or in whatever. Okay, so we use index to look up other arrays we want to do once we've done parallel arrays. Okay. If you wanted to keep track of the index location here of where the item was, you could declare another field called index. Okay, and set it to -1, so not found. Okay, and then set index is equal to k. Okay, so that's one way to do it. Or else you could use index here, take that out and say index equals 0 there instead of int k. Index is less than that, index plus plus, and add 1 to index plus plus here, index plus plus, and then loop through and just keep track of index. But then you couldn't exit the loop that way because that would make your index invalid. So this is probably a better way to do it. Keep a separate index, set index to k, and then set k to the valid value's length so that you exit the loop next time through. That's a better way to do it. Okay. Or else if you're going to use a while loop, you can use a while loop as well, or you can use a do while loop. Have a play around, see what you find. Okay. So parallel arrays, one with the same number of elements as another, and the values in corresponding elements are related. So here we had, so one array's product codes, the element here, the product code matches that keyboard, matches that price, matches that quantity in stock. And for 32 gig memory rate, that's the product code, that's the description, that's the price, that's the quantity in stock. So you've got to keep all the arrays perfectly in line. Okay. You've got to be very, very careful if you sort. If you want to sort that array by product name, you'll be super careful to do all the same swaps on these other arrays as well, every other array. Okay. So here's an example. We've got valid values and prices. So valid item is true. We've found a match. They've entered an item. We've looked up the valid values array, and then we're getting the price for that value. Okay, so item price equals prices for that index location. Okay, and then we can display that down here. If valid item is true, we could display the details. Otherwise, we could say not a valid item. And that's exiting early, like I said earlier. So set it equal to whatever the loop control variable is, or so it no longer satisfies the loop, the length or the max, whatever the size is for the array, max items or whatever it is you've declared. But either way, you're exiting the loop. And I would also always suggest putting on that comment on that line of code. Exit loop, just to make it really clear that's what you're doing. And here, / exit loop. Okay, make it really clear that's what you're doing. Searching. Okay, so with parallel arrays, because there's this issue, if you sort one array, you've got to keep everything in order, and it becomes really messy really fast. Maybe a better way to store this same data is to create a product class. Private double price and int private int apostrophe, stock. And you could have constructors, you could have your mutators, you have your accessors, you could have your toString. And in another class, you could create an array of that product class. So products, final int max size is equal to 10. Okay, so create an array of size products, and then call the and then create products and use the mutators and accessors and toString method to work with products. That is a much better solution. Much better. This is the old way people had to do things before object-oriented programming came out. Okay, so late 70s, early 80s, this is the way people had to write their code. These days, nobody writes their code this way. So it's much better, much cleaner. Okay, just to store your data this way, and then create an array of that class. Okay, and that way, if you do need to swap products around in the array, so product. So you could say product temp equals product 0. Okay, so this is swapping two items in the array. Product temp is the current product 0. Product 0 is product 4. So we're moving product 4 down into product 0's location, and then restoring the original product 0, which is now in temp. So product 4 equals temp. Okay, so it's swapping the memory addresses around for the various products. Okay, so that's much easier. So you get to sort one array or sort the elements in one array. It's much easier than sorting 4 arrays or 10 arrays or whatever. Okay. And if you sort by product name and you move 2 elements around, you've got to make sure you move exactly the same 2 elements here and here and here. So it's a lot of work and a lot of complexity for something that could be much simpler. Okay, so much better solution. So use OOP, object-oriented programming. Okay, much better. Create a class and create it with all your setters and mutators and accessors and toString and any other methods where you're used to creating, and then create an array that. Give it a max size. Okay. So anyway, that's something we'll talk about more in the tutes, and it's certainly relevant to your second assignment. Okay, so we've got an example coming up where you're searching for a match in the array, but in a range. Okay, so you want to see if they've entered 0 to 5. So you might have different discount rates, something like that. If they enter 0 to 5 items, you get 0% discount. 0%. If they order from 6 to 10 items, they might get a 5% discount. And if they enter 10 items to 20, they might get a 15% discount, and so on. Okay, so you might not be searching for an exact match. You might be searching for a range of values. See if your value is in that range, and if it is in that range, then you might want to return the discount percent or something like that. Okay, so that's quite a common thing to do as well. Range searches. So here's an example. So discount range limits. So from one product order to 13 or 12, depending on how you want to do it. So in that range, there's 0% discount. When it's between 13 and less than 50, then it's 10% discount. When it's 50 to 100, it's 14. When it's 100 to 200, it's 18. And when it's greater than 200, it's 20% discount. Okay. I recommend when you create these arrays, like I said, keep everything in order. So I would put a couple of spaces there, a bunch of spaces. Keep everything in order, nice and neat. And above it, especially while you're getting used to working with arrays, do this. Put the index numbers there as well, 0, 1, 2, 3, and so on. It'll save you so much problems and so much hassle later on if you keep your code neat and put the index numbers there as well. Just as a comment, it's a / comment. You set that to the top of your array or arrays. Okay, so we're getting okay, so the user's not entering any data. Oh, we're entering via dialog here. Show input dialog. How many items are ordered? So we're getting the number ordered there. String number ordered. Remember, everything comes back from an input dialog as a string. So then you've got to convert it to an int. Number ordered equals integer.parseInt string number ordered. So we're converting the string they entered to an integer. And while sub is greater than equal to 0 and num ordered is less than discount range limits square bracket sub. So we're looking at these values here. Okay, and starting off with sub equal to sub equals number of ranges -1. So we're starting off at the far side of the array. Okay. So while sub's greater than equal to 0 and number ordered is less than the discount range limit sub, take 1 off sub. Okay, so we start at 200. If we enter the value 5 for a number ordered, 5's less than 200. So we'll keep looping. Sub's still greater than 0. Next one, 100. Yep, we're less than 100. Loop again. We're less than 50. Loop again. We're less than 13. Loop again. And we're now in this range here. So customer discount equals discount rates square bracket sub, whatever the subscript value, the index, in other words, sub or subscript, just another name for index. Okay, so that's just the index. So get the discount rate for that item, and then we can display it. Discount rate for 5 items is, and then the discount rate, which would be one of these values here. We're looking up the discount rate array. Okay, so if we're in that range, we'll get that discount. If we're in that range, we'll get that if we're over that range, we'll get that discount. If we're in this range, 100 to 200, we'll get 0.18% discount. If we're in 50 to 100 range, we'll get 0.14. If we're in 13 to 50, we'll get 10%. If we're in 1 to 13, we'll get 0% discount. Okay, so quite common processing, and you can loop down if you want like this. This is starting at this side of the array and working backwards, or you can start here and work up until you don't find a match, until you exceeded the discount lower limit. Okay, then you can just take K1 off the subscript or index and use that prior range. Okay, so quite common sort of code. Okay, so pass by element, pass by value, pass by so when you pass, if I've got a method, in fact, let's have a look at some code. This is some code I prepared earlier. So just focus on this one for now. Public static void parseInt. I'm passing in an integer value and I'm trying to change it. So whatever value is passed in, I'm changing it to 999. Okay. Down here in my main program, I'm creating an integer called val, setting it to 23. I'm looking at the value before I call the method. So I'm just displaying the int before and displaying val to the screen. And then I'm passing the int val to the method, parseInt. So I'm calling this method up here, passing through val, whatever value val's got to the method. And then after the method, has val changed? Okay. And we have talked about this before, but we said that all primitive types passed by value. In other words, and passed by value to a method. If the method changes the value, this has no effect on the caller. Okay, so if the method changes the value, this has no effect. Okay, so here I'm passing through the value. Oops, sorry, wrong one. Passing through the value 23 to parseInt, and the parseInt method changes it, but that's got no effect back in the calling method. Okay, so back here, I should still see the value 23. Let's run the code and check. And we do. So before and after. So that applies to all primitive types. So that applies to int, double, boolean, char, and so on. Short, byte, and the other ones as well. Float, long, all those ones are all primitive types. Now, reference types, when you call a method and you use a reference type, for example, a string or a date or an employee, then something different happens. The memory address of the data is actually passed. So let's have a look at the effect of that. Okay. And an array is a reference type. So let's have a look at the effect on an array. I've got an array with 3 items here, 10, 20, and 30, 3 elements. And I'm using the arrays class method toString to get a nice string representation of my data. So it's going to display the values 10, 20, 30. Okay, so that's not a bad thing to keep in mind if you're using it. You've got to do an import for it. Yeah, import javutil.arrays. Okay, so not a bad way to get a string representation of your data. And it works for any type of array, an array of strings, an array of employees, an array of anything. Okay, it'll give you a string representation of your data. Okay, and then after, so we call a method changeIntArray and pass through our array, and then after the method call, we display the array's values back to the screen again. Okay, and I've just told you that this is a reference type, so we're passing in the memory address of this data, where this data lives, we're passing in the memory address. So this method can change the data. Let's have a look at the method, changeInt. We're accepting an array of integers, and I'm setting the value at location 0 to 99. So I've got an array of 3 elements, and I changed the first one. And you've got to ask yourself now, is the change reflected back in the calling program? And it is. Okay, so before it was 10, 20, 30. After, it's going to be 99, 20, 30. Let's run our code and check. So this is before, 10, 20, 30, and after, 99, 20, 30. So when you pass arrays to methods, you've got to be super careful. You've got to keep in mind the array can change the data, or the method can change the data. Okay, so if you didn't want that method to change your data and it's changed it, then your data is now corrupted. Okay, so you've got to be super careful. Let's look at one more. We might look at a couple more. Let's look at an employee. So I've got a standard employee class, the one we did last week. Employee, we've got 2 data, two class fields or 2 instance fields. The default constructor, parameterized constructors, the mutators, set ID, set name. I probably shouldn't call it student, I'll probably just call it ID. It's just ID. It's not student ID for an employee, is it? Okay, so I'll change it to ID. ID, ID, and ID, sorry. Shouldn't have been student ID. And set, I could have called it employee ID instead. ID, ID, ID. And get ID. And the last one is the ID here. That should be right. Control 1. Yeah. Okay, and then over here, I create an employee. Employee E1 equals new employee, Mike and 123. Okay, so I'm calling the parameterized constructor. Then I'm displaying that employee to the screen with E1.toString. So I'm calling the toString method. which we've looked at in prior weeks. Just getting a string representation of our data. So name followed by the ID inside round brackets. And then I'm calling change employee, and I'm passing through the employee, which is passing through the memory address of where our data lives. Okay, so change employee. So change employee's got our employee, an employee object, and I'm calling the set name method and a set ID method for that employee. I'm changing the details for that employee. Okay, and then displaying the employee back here. So after that method's been called, I'm displaying them as well. So I can see whether it's changed before or after. And can you guess if it's changed? And yes, it has changed. Just going to comment out some more code. Okay, so there's the employee before I called the method, Mike123, and Frankie after I've called the method, Frankie567. So the changes that were made to the employee here are reflected back in the calling program. The changes that were made to the array here are reflected back in the calling program. Okay. Let's just try one more. I don't want to confuse people, but let's just try one more because we are going a little bit beyond the scope here. We'll just do one more, okay? So let's do it with string. Okay, so I've got a string called Mike, and before it's going to be Mike, isn't it? Then I'm passing the string to this change string method, and change string method takes in a string and sets it equal to I feel changed. Okay, so it starts off as Mike, and then we pass it to this method where the string is changed. And what do you think the answer is going to be when we display the value after the method call? So before it was Mike, what's it going to be after? Let's compile and run. It's still Mike. The method changed the string, but the value after the method call is still Mike. What on earth's going on? What on earth is going on? Okay. And I don't want to go too deep into this because this is something we'll talk about more later on and in the following course. But you look at my little note here. String is immutable. String is an immutable class in Java, which means if I ever change a string, it's a different memory location. Okay. So I've passed through the memory address of the data that contain the string Mike, and I've changed the string. So this is allocating a new memory address. So string is now referring to a new location in memory where it's a new bit of data. I feel changed is stored there. But the original string is still pointing to the original bit of string data, which is Mike. So when I display it to the string, it's still at the value Mike. So I'm changing string here, but this is allocating new memory and new data. Okay, so this new data at a new memory location. And that's not where the value, the memory name is pointing. Name is still pointing to where it originally pointed, which is still at the value Mike. Okay, so reference types are passed by reference to methods, the memory address is passed across. And in general terms, the method can change the data, but you've got to be careful because some data is immutable. Okay. So in general terms, reference types, the memory address is passed to the method, and the method can change data. Okay. Be careful. That's all I can say for now. Be careful. Now, there are strategies that we could talk about to deal with this, but they're outside the scope of this course. Okay. For example, you could create a copy of the object and pass the copy. You could restrict it so the object is a constant so that nothing can change it. There's various things you could do, but these are sort of outside the scope of what we talk about in this course. So these are solutions. These are all outside the scope for us. We'll talk about it more a little bit later in this course and in the follow-on course. But we haven't done enough Java yet to really understand what's going on, and I don't want to confuse people. We probably have done enough Java, but to talk about these things and understand them more, we need to dive deeper, and I don't want to do that just now. So just remember, all primitive types are passed by value. Okay, so if you pass an integer or a Boolean or a char to a method, it cannot affect the call program. The caller can't be affected. Okay, so the original values back in the caller are unaffected by anything the method does. But when you pass by reference, assume that the data can be changed. Okay. So reference types holds a memory address where the values are located, or the data is located, where the array lives, or where the employee lives, or where the array of employees live. So if you're passing that memory address to a method, that method can change that data. So the receiving method gets a copy of the actual memory address, and the receiving method then has the ability to alter the original data. And if that's not something you want to allow, if this method is bypassing your validation rules, then your data is now corrupted and it cannot be trusted. Okay, so you've got to be super, super careful. Be careful, super careful. Especially when you're passing, it's not just passing methods or reference types to your own methods. You might be passing them to another class that you didn't write, or you might be passing it to another class that your company didn't write. So you might not even have the source code. Okay, in which case you've got to be super, super, super careful, because that class could be bypassing all your validation rules and corrupting your data, or just making even subtle changes that only occur every now and again. Okay, for every Friday, if you're giving a pay rise on a Friday between 12 and 1, this method could do sneaky stuff with your data. So you'll be very, very careful. So reference types. So string, employee, date, arrays, etc. For all those reference types, the memory addresses pass the method, and you'll be super, super careful. So here's a little example here. So we've got some elements, and we're passing them to a method, but we're passing it just one at a time. So we're not passing the array to the method. We're just passing the value of one element in the array, which is just a standard integer. Okay, so any changes done to this integer inside here will not be reflected back here. Okay, and so here I'm calling some nums with x for x, which is just setting an element to 99, but it's only local inside here because it's an integer. Okay, if I pass the array as a whole, this method could change the data in the array. Okay, but I'm just passing a single integer. So at the start of the method, the value is whatever the value is passed across. So it'll be 5 for the first one. At the end of the method, the value it'll be 999. But back in our calling method, it's still these original values after the method's been called. Okay, so the array is not passed, just an array element is passed, and each array element is just a simple integer. It's an array of int. If this is an array of employees, and we passed each employee across, then that's passing the memory address of the employee, so it could be changed. Okay, but we're just passing an array of ints. And each integer is just a plain old integer, just a primitive type. So nothing done to the data here can be reflected back in the calling program. Any method can, okay, so keep that in mind. Save a bit of to do for page 27 or slide 27. Student to do would be to adapt this code to pass the array and change the array and see if it changed back the calling method. It's the main program in this case. That's another student to do there. Okay. And you can see for yourself how the calling method can change the data. Okay, so pass the array, not just a single integer, pass the array of integers. So it'll be int square brackets followed by array. And you'll pass that whole array in. Okay, so, and you won't call it like this. You won't call it for each element. You'll call it just for the array as a whole. So just one call, not 4 calls. Okay. Now, a method can return an array reference, and you include square brackets with the return type in the method header. Oh, and that's it. Okay, so we've seen methods that can return employees or public. So methods can return strings, and methods can return dates as well, public date, whatever you want to call the method. And so we can return you might want to do various processing on that date, and then at the end you're going to return the date. Okay, so they can return dates, that's fine. And because it's just a memory address of where the data is, so that's fine. And you can pass through, if you had an array of ints, you could pass that through to a method, or get it returned from a method, or both. Here I'll declare it inside the method here, and I'll pass it back. Okay, so I've got an array of ints there. I'm doing some processing on it. I don't know what, and the last line of code is I'm returning that array. So I'm returning this object, which is an array of ints. It's in square brackets. So your method name's going to be int square brackets. And I could also pass an employee public, or get an employee back. Whatever processing I need to, and then return them. So then I'm returning an employee. And I can also do it with an array of employees as well. So employee emps equals new employee. I could pass that array to a method, public. I could pass it to a method to read from file, read, or get user input. Pass in the array. Down here, I could and I'm just returning a Boolean, so I could return a true at the end or false. So I could check each employee, check if they're all valid, and then return. So I'd call this by passing in an array of employees and get back a Boolean. So I could say, I'll move this down here with this. So I'm passing through the array to the method. Okay. So declare employees. Want to get user input. Next int, or whatever, however you want to get it from the keyboard or whatever, and set name. So for each employee, set the names. And of course, you might want to do this in loops. This might be a K, 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 and you might be doing that in a loop. Like we talked about earlier. Okay. And that's probably all I want to. Oh, and also getting an array of employees back. So here we're passing an array of employees. You could also get an array of employees back. Get employees. What are you going to call the method? You could pass in any data you need to pass in, however many you want to get. But whatever data is coming back is an employee array. Okay, so whatever the return type is, must match whatever you're returning. So if that's an employee array, you've got to return an employee array. So EMS is an employee array. Here I'm returning a Boolean, so all valid's a Boolean, return all valid. And here I'm returning an integer array, so I'm returning nums, which is our integer array. Whatever name you want to come up with there, and parameters you want to pass, whatever you want to do. But here I'm returning a date, so I've got to return a date, and so on. Here I've got to return an employee, public employee, get employee, and get the employee, get user input, do your validations, and then return that employee. Okay, but it's a single employee, so it's employee without square brackets. It's just a single employee. Okay, so you could even call this one from down here if you wanted to. And let it do this work. So this get employees method would do all this sort of stuff up here. Validations and all that as well. Okay, so here we've got a method that returns an employee. Here the array needs an employee. So we're going to say emps array square brackets equals get employee. Okay, so let's fix up the call. So you can take it all out if you want and just call the get employee method. Emps array k equals get employee. So that does the new employee, does the getting from the user, does the validations, checks everything's okay, and then it returns the employee. So that's quite a nice neat design, that one. Chop, chop. And so on. So this loop here, you could, if you've got 100 employees, you could ask the user if they want to enter another and bail out early if they don't want to enter another, just like we looked at earlier. Okay, and that's it for this week. So arrays. So we talked about arrays. We've also talked about pass by value, pass by reference, methods, and also talked about parallel arrays, arrays of objects, which is a much better way to go. We'll talk about this a lot more especially this one. We'll talk about this one a lot in the tute coming up because it's a big part of your assignment, second assignment, and so on. By reference, dangers, issues, and but we haven't exhausted that topic by any means because there's a whole lot more we could say and we can't say it yet. Okay, so that's it for the lecture. Hope that was useful. Thanks for watching and have a nice day.